Okay, welcome to our study of pre-calculus. I am doing what I can to help you out. If you think I am making a mistake, there is a good chance I'm making a mistake. So please tell me. It's okay. Growth mindset is all about learning and doing better. Right now we have a small class. We just have one other person, which just makes me even feel way better. And it's someone who I love. Yay. So basically what we're going to do is I looked over the blueprint, and the blueprint tells me how many standards and how many questions about each standard are going to be on your test. And I also looked at the conversion chart. And in order to get a passing grade of 70 on the conversion chart, you need to answer 14 questions correctly. So what I did is I found the standards that relate to about 12 questions. So hopefully we'll be able to focus on those, and that plus either good luck or you knowing other topics that I'm not covering today is going to get you to the passing grade. I don't know how long this is going to take. We weren't going to play Kahoot anyway because this is definitely like an area of growth for me. And we're just going to go from there. So I have a TI-83 emulator. Oh yeah, I was going to post for you the link. So if you have access to a printer at home, that is the link of what I'm doing. If you don't have pre-calc first period, I will definitely be willing to print copies out that you'll be able to take and follow along with that. Okay, so the first thing we're going to talk about is the AKS 14, which says, understand that radian measure of an angle as the length of the arc on the unit circle subtended by the angle. Well, that's pretty much a whole, oh, there goes my water. That's just a whole lot of conversation to basically say unit circle. Remember, anytime that we have the unit circle, it's talking about a circle with a radius of 1. That's the unit circle. And what it means that the radian measure of an angle subtended, basically all that means is if you have an angle, like this, subtend means that it touches the circumference of the circle. That's all that subtend means. And hopefully you might remember from geometry class that when we had that, we had the central angle was in the center. And we talked about how the degree measure was the measure of the arc in degrees. So the only difference here is we're talking about radians. And so there's 3 questions, 1 easy question, 2 medium questions that relate to this, is understanding radian measure as it relates to the angle and the arc length. So let's take a look at a question. Excuse me. Here, it gives us that reference angle, and it wants us to convert it into radians. So if we start here, there's a couple things to remember. Anytime that we have pi, that equals 180 degrees. Anytime that we go from degrees to radians, what we're going to do is we're going to have to multiply by pi over 180. So the next thing you have to remember is direction. And back in the day, we talked about that you would label these quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we said when we go in this direction, we would be going in a counterclockwise direction. When we go in any other direction, that would have us going in a clockwise direction. So if we started this way and went down, this is going clockwise. And that makes sense because if you think of a clock, going down this way is clockwise. Now, when we go up something, so for example, if we started here and moved up, we're going in a positive direction. So our angle measure is going to usually be something with a positive. Here, when we go down, that's a negative direction. So in this case, our angle measure is going down. And actually, this just says find the measure of each angle. Let me see if it wants us to do it in, oh, it does. We're not necessarily converting to radians yet. Okay, so here, because this angle is going in a 90 degrees, because it's going down, we know that our answer is going to be negative because it's going down. Then remember, in a full circle is 360 degrees. So every time we have a quadrant, that's just 90 degrees. So if we go down from here to here, we know this measure is 90 degrees. And then it tells us that from here to here, it's 20. So all we're doing is adding 90 plus 20 to get negative 110 degrees, which is the correct answer. Now, let's say we wanted to take that degree measure and move it to radians. Remember, anytime we do radians, we always do pi over 180. The reason why we do pi over 180 is, first of all, it's kind of like when you were doing units and you had to convert feet to inches, and we had to make sure that you had feet on the top and feet on the bottom so they could cross out, that type of thing. That's kind of what this is. Basically, you're putting pi, which is the radian measure, over the degrees to allow us to cancel out the degrees. So if we were going to convert this to radians, all we do is multiply it by pi over 180. Now, there's a couple ways that you can do it. You can do it in your calculator. So if I went and did it in my calculator, turn my calculator on, I know my answer is going to be negative because this is negative. So I've got 110 pi over 180 because my degrees canceled out. So I could, on my calculator, do 110 divided by 180, and I get a decimal. But we don't like decimals when it comes to radians. We need to have fractions. So that's when you're going to click Math and click that fraction, how it's on the 1. It's the first thing. Now it's going to change it to a fraction. So we know that the real answer is negative 11 pi over 18. And that would be the radian measure. Let's take a look at another one. Mouse. Perfect. Okay. This one's crazy because we're looping it a whole lot. And with us looping it a whole lot, we just have to keep adding 360 plus 360 to count for every single loop that we do. So because this is in degrees, I'm going to leave my first answer in degrees. First, I check the direction. It starts here and it proceeds down. So I know no matter what, my degree measure is going to be negative. I also know that every time I go around, it's going to equal 360 degrees. So if I go here, I go one time, so I've got 360 there. Then I just do it again. I start where I left off. There's another 360 degrees. Then I keep going. Well, here is 90. Here is 90. And then here, I don't know how much this extra little piece is. But that's what when you need to go a little bit further and just think, okay, well, if this whole thing is 90 degrees and I subtract 50 degrees, how many degrees are left? 40. And so then I would add the 40. And then on the calculator, now in real life, I probably would have just typed all of this right into the calculator, but I didn't want people to get confused. So I've got 360 plus 360 plus our two 90s for each of the bottom quadrants, plus that additional 40. And that gives me 940, which is got when I did this problem before. So the answer to this problem is negative 940 degrees. Now again, if we want to convert degrees to radians, we know we have negative 940 degrees in the numerator. Pi has to go in the top, and 180 goes in the bottom, and we know 180 degrees goes in the bottom, so we can cross out our degree measures. We also know pi goes in the top because when we do radians, the pi is part of the radians. Then I just go back to my calculator, and I do, well, what's 940 divided by 180? I get a decimal. So I hit Math, fraction, enter again, and I get 47 over 9. I've got my pi, and again, I know it's negative because I start going down. All right, we're going to do a couple more here, this time where they give it to us in radians. The other thing that happens this time is when we start by going up. So because we're going up, we know it's going to be positive. Here, it was negative because we started going down. Here, it was negative because we started drawing the circle down. Here, our answer is going to be positive because we start by drawing the circle up. Now, this is just a trick that I do. You could have another strategy. What I like to do is I like to think, okay, see how this says pi over 6? That means my denominator is 6. And that means that each one of these piece sections has to be broken up into 6. 1, 2, 3, 4, 5, 6. And I could also do it on the bottom. Each of these sections, technically each of the 90 degrees have to be broken up in thirds because that's how I have to do it. If I think of 180 degrees into 6 sections, I know each section is going to be 30 degrees. So here, when I'm looking, well, what's this measure? Well, if I start here and I go one time all the way around, first I went 6 pi over 6 around, because 1, 2, 3, 4, 5, 6. Then I did it again, 1, 2, 3, 4, 5, 6. And then here I count my last part. 1, 2, 3, 4. So then I'm going to add 4 pi over 6. Now, these are just fractions. Pretend the pi is an x. You don't do anything with the pi. You just add. 6 plus 4 is 10. 10 plus 6 is 16. 16 over 6. You can reduce the fraction. 2 goes into each of these, like here. So we know our answer is 8 pi over 3. Is that what I got when I did it before? Yay! It is. Okay. One more of the ones with the circle. Okay, again, here I'm starting. I know I'm going in a positive direction, so I know my answer is positive. I go all the way around once. Okay, and I'm here. Well, each one of these sections is 4. So I know that every 80 degrees, every 180, I have to bring fourths. So here's 1/4, 2/4, 3/4, 4/4. And because we know 4 pi over 4 equals 1, that's correct, 1 whole. So that's just our pi. So that's how we have that piece. So now all we do is count from here to here. That was our 4/4, or 4 pi over 4. Then we continued again. You know what? I got too much going on with all this. Let's just delete this so I can do this one more time. And I can see. Okay, so first we have 4/4 there, plus another 4/4. That takes us all the way around. Then we're going to keep going. Here's another 4/4, or rather 4 pi over 4. Here's another 4 pi over 4. And then finally, we don't know what this is, but we know that each of those sections are worth pi over 4, because that's how we divided it. So really, we know this is just plain pi over 4. And then we add it up. 4 plus 4 plus 4 plus 4 plus 1 is 17. And then our denominator stays the same. And again, it's going to be positive because it's going up. Okay, so that is about 2 to 3 questions of your test. The only other thing I can think about is maybe they might ask you to do the reference angle. So here is just one way that you can do it. This is how I do it. I'm not saying it's the best way. I'm just saying it's the way that's worked for me. So what I do is I think of like back in the day, 3rd grade division. And the reference angle is if we have a triangle like this, and we said this is the measure, the reference angle is this one. It's like the angle from where the radius ends to the flat side of pi. Also, for example, it could be any way. Okay, you could have a reference angle over here, and this would just be the reference angle. It's from the line to pi. So this is the way I do it. I'm not saying it's the right way, but it's helped me. Here we have negative 47 pi over 12. So first I say, okay, well, how many times does 12 go into 47? Well, if I do it 3 times, I have a remainder of 11. So I know I am going to go 3 times around with a remainder of 11. So then I just kind of sketch it. Okay, because it's negative, I know I'm going this way. So there's 1 time around. I have to go 3 times around, 2 times around, and I run out of space. 3 times around. So that has just taken care of my whole numbers. Now I need to move 11 times around. Well, I know all the way around is 12. And if I'm only moving 11, I know I'm going to be left with 12 minus 1. I'm sorry. 12 minus 11, which is just 1. So really, that's it. My reference angle is going to be 1 pi over 12, which we would just say is pi over 12, because that's all that's left after all those times going around. When we did this and we went 11/12 of the way, how many twelfths was left to get to 0? 1/12. So that's what the reference angle would be. Let's take a look here with something that doesn't have as large of a denominator. Again, I do my old school division, and I get a remainder of 1. I draw my chart or my unit circle, sketch, and because this is negative, I'm going to start at 0 and I'm going to go down. I know I have to go 1 time all the way around to represent my whole number. Check. Then I have to go 1/4 of the way. So 1/4 of the way is just to right here. So then my reference angle, let me make sure I did this correctly. I did, is simply, oh, that's what I messed up. I didn't. I forgot we have to divide these into fourths. So my reference angle is going to be pi over 4, because that's what I have left. Did I do this one right? Pi over 12. Yep. Okay. So that's pretty much it for there. Next. That's the same one we just did. No, it's not. So here, same idea. We're going in a negative direction. Okay. We're doing it in fourths. So here we have here. Boom. Again, the 9 plus the other one, and I'm left with the 1/4 as the reference angle. If you have a number that's bigger, I would say probably the easiest way to do it is to just keep subtracting 360. So here how we have 530. First we minus 360. That gives us 170. So we know that when we start here and we go 360 degrees, we know we have to go another 170. Well, remember, we always want to get to the 0. So if I go 170, that means I went 90 degrees here, 80 degrees here, so my reference angle is just going to be 10. If I look here, it's the same concept. I start at 0. It says negative, so I'm going this way. This represents 90. I go 50 more and draw my line. How much do I have left for my reference angle? 40 degrees. And that's it. Okay? Your reference angles will always be positive because it's an angle in a triangle. All right, so that is my best guess for those 3 questions. Now it says use special triangles to determine geometrically the values of sine, cosine, tangent for blah, 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 and use the unit circle to express sine, cosine, tangent for all those other measurements. There's going to be 1 easy one and 2 challenging ones on this test. So this is what I thought was so cool. On your test, you actually get to have somewhere a formula sheet. And I'm sure your teachers have been awesome in showing it to you the whole time. But like, this is one of the things I kind of laughed at because I watched this whole video teaching me how to use the formula or how to make the unit circle. And then when you look at your formula sheet, the unit circle's on the second page. So I spent all this time trying to teach you to learn how to do it so I could teach it to you, and it's literally on the page. Okay. The other thing is most kids get like, what's cosine, what's sine? Dude, it literally says it on the formula sheet. So please, for these 3 questions, make the formula sheet your best friend. It's going to make your life a whole lot easier. The only thing the formula sheet kind of neglects to tell you is that the radius is going to be your hypotenuse for when you do your trig functions. The other thing I was surprised by is I didn't notice it having like sine theta equals 1, or I'm sorry, cosecant theta equals 1 over sine theta, like that part. They didn't have that either. Okay, so let's look here. Number 3. It wants us, let me find my notes so I give us the proper directions and not mess it up. It says find the exact value of each trigonometric function. So this says 510 degrees. So first what we're going to do is we need to convert it into radians, because by converting it into radians, it's going to make it a lot easier to use the unit circle table. So how do we convert it to radians? Same way I already showed you. You have 510 degrees, and all we're going to do is keep subtracting 360 till we get a value. So I'm going to do 510 minus 360, 150. Okay, so we know that from here to here, we did 360. We know from here to here is 150. So we know that our reference angle is going to be 30 degrees. And our reference angle is 30 degrees because we take 180 degrees, we subtract the 150 that we move, and now we know we've got 30. Now, here's a hint that you can do. When you look at the circle, remember the most important angles are 30, 45, 60, and then technically 90. So here, you might want to do this if you're allowed to write on your formula sheet. And you can just go like this, 30, 45, 60. All of the measures come off of pi. So from here to here, again, you're looking at 30, 45, and 60. Well, since we know our reference angle is 30 degrees, all we need to do is go, okay, well, 30 degrees, that's going to give me, well, that's what's left for here. It's going to give me this value, 5 pi over 6. Now, the other thing that you could have done is you could have just taken that 150 and you could have immediately just converted to radians. And now in hindsight, that's probably what I would have done instead. Remember, to convert to radians is just pi over 180. So here, I'm going to just do the math because I like to just reduce, but you can also reduce it in your calculator. Actually, let me show you so you know. I've got 15 divided by 18 in my calculator. It gives me a decimal, so I hit math fraction, enter again, and it tells me that it's 5/6, which is what I just had. And if you can see, 5/6 gives you this value. Now, we're not quite done yet. Here it tells us the square root of 2. I'm sorry, this is the coordinates they give us. Okay, that's the point here. Now remember, literally on your formula sheet, it tells you that sine theta is the y term. So I just have to look here and say, okay, well, if sine theta is the y term, then my answer is 1/2. Now in real life, it will not take you that long to do this problem. I'm just trying to explain it as I go, pretending that you've never learned it before. Let's take a look here. Woo! Here it says 585. So it wants cosine of 585. So what you can do is, well, we can look going around. We know that this right here all the way around is going to give us the 360. And we know from here to here we have 180. So in my calculator, I would type 585 because that's our original. I'm going to subtract the 360 degrees for the one whole time around. Then I'm going to subtract the 180 degrees for the half a time around. And I see that what I have left is 45 degrees. Now I go to my unit circle. Remember, the line closest is going to be 30, then 45, then 60. 30, 45, 60. I see that when I move 45 degrees, this is what I get. Negative square root of 2 over 2. Negative square root of 2 over 2. Well, I know that my first term, my x value, is really cos. And I know my second term, or my y, is really sine. So in this case, my answer is, wow, did they get something different? Hold on. Hold on, all of a sudden I'm doubting myself. No, I'm right. What they get is negative square root of 2 over 2. And that's your cosine value. So this would be your answer right here. Okay. Let's look at another one. Here we're going around a gazillion times. So we can do it kind of thinking how we have the fourths if we want. Okay. This is fourths for 1 pi, 2 pi, keep going around and around. Or you can do it the way I showed you. Okay, we know we have 1/4 left. Looking at our image, we know our 1/4, or pi over 4, is going to be located right here. So what do? Well, here's our 30, here's our 45, here's our 60. Our pi over 4 would represent this line right here. Boom. Now, this is where it gets a little bit tricky. You do have to remember that tangent is opposite over adjacent, or technically I want you to think of it as your y value divided by your x value. So in this case, we have the negative square root over 2 over 2, divided by the square root of 2 over 2. Well, we know that whenever we divide fractions, all we need to do is flip it and multiply by the reciprocal is the technical math terminology. When I do that, I can see that these 2's reduce, the square roots cancel, so I'm left with -1, which is the correct answer. Okay, remember, we're trying to figure out how to get 3 questions in this section. Cosine 9 pi over 4. Okay, again, you can do, well, 4 goes into 9 2 times, 8 with 1/4 remainder. Okay, so I'm going to start at 0. It's positive. So here's 1/4, 2/4, 3/4, 4/4, and then we just keep going. 5/4, 6/4 is down here, 7, 8, and then I get my 9/4. So this is the reference line I care about, which is the square root of 2, like this. It wants cosine, so it wants the x value. And look at, it says it right here, the first number. So the answer is the square root of 2 over 2. All right, let's look at another one. This takes it a little bit more challenging. It doesn't want to know what the theta is, which is what I got confused when I was doing this. And really, I don't think that you need the unit circle. Instead, it wants to know what the sine is. And you should have remember, in my classroom, we had this really annoying song that was, you know what it is, Sokotoa, Sokotoa. And it was like you were going to end up getting like a heart attack or a seizure from everything. Instead, what you're going to do is how we have opposite over hypotenuse. Really, I just want you to think of sine theta as the y value divided by the radius. Your cosine theta is going to be your x value divided by the radius. And we don't need you. And your tan theta is going to be your x, sugar shoots, your y value divided by your x value. So in sine and cosine, the hypotenuse is the radius, and tangent, you have y and x. So in this case, it wants sine. Well, if you can see, if I go like this, I actually have a triangle. And it's created by my reference angle theta, and it tells me my coordinates are the square root of 15 and 7. Well, remember that square root of 15 is just the x value. So I know this side right here is worth the square root of 15. I know my height is 7 because that's my y value. What I need to do is do Pythagorean Theorem to come up with my c squared. So this is another formula you're going to have to memorize. Now, you might have learned another way to do this problem. This is the only way I could figure out. So I'm not saying it's the best way. I'm saying it's the way I figured out how to do this. When I add this up, I get c equals 8. So now I'm going to put 8 up here. So this says it wants sine. Well, I know sine is the y value over the radius. What's my y value? My y value is 7. What's my radius? 8. So my solution is 7/8. Okay, let me switch to the correct thing. Yep, that's what I got. Perfect. All right, let's take a look at another example. And actually, this whole idea of thinking of it as xy over the radius, I actually took that from one of the videos on gwynetmath.com that I found when I was teaching myself how to do this. All right, again, we have another triangle. We know that our x value is going to be here. Our y value, I still will write the negative 13, but really it doesn't matter because when you square it, it's going to be positive. And we need to find this value. So I've got 17 squared plus, don't forget to put the negative in parentheses, like this. I think 17 squared is 284. Oop, good thing I checked. 289 plus 169 equals c squared. 289 plus 169 gives me 458. And then when we take the square root, we get a really ugly number. Okay, so this one's cotangent. Remember, cotangent is just tangent flipped upside down. So if the real tangent is opposite over adjacent, or rather y over x, cotangent, and this is also on your formula sheet, is the opposite. So now I have to say, okay, well, this goes here. Oh, I actually didn't even have to figure out the radius. Jeez. All right, cotangent is x over y. Well, my x value is 17. My y value is negative 13, and we know proper math, we would never write it like that. So we get negative 17 over 13 for question 16, which is the correct answer again. Yay, us. Okay, I don't want to do any more of these types of problems because I think I've covered it enough. Now we're going to talk about the one question on multiplying scalars. Holy moly, it is super easy how to do this. Now, I wish I knew how to use a graphing calculator before I did all of this work on paper and by hand. And then, like, almost at the end, I was like, wait, matrices can be done in the graphing calculator? Why am I doing all this extra work? It makes no sense. So we will take a look at these just to get you started. Let me get my answer key for this because I don't want to mess you up. That would really, really suck. Okay. What number? 1 is A. Negative 5. We got it. We got it. Okay. Here, now, sometimes you can just do it in your head. So like this would be an example where it tells you the matrices. Now, when we have this matrice, this is called a 2 by 2. And it's called a 2 by 2 because there's 2 rows, 1, 2, and there's 2 columns. Blue. Okay, so that is why it's called a 2 by 2. Now, whenever you're multiplying by a scalar, it's ridiculously easy. All you do is you distribute the number to all of the other numbers. So for example, I've got 2 times negative 15, sugar shoots, 2 times negative 5, which gives me negative 10. So immediately I can eliminate choice B and C. Then I've got 2 times negative 8, which gives me negative 16. So I can eliminate choice A. My answer is D. But for good measure, 2 times negative 1 is negative 2. And 2 times negative 4 is negative 8. So that's your answer. That's literally it. Now, this is what you could have done instead. You could have, I'm going to clear my screen. I could have hit second and then see right above the x negative 1, it says matrix. That's what I could have started off by doing. Now there's 3 categories. There's names, there's math where it wants you to, you could find like the determinant. I honestly don't know if you have to do that in PreCalc. And edit. Edit is where we're going to put all of our numbers. So I'm going to edit matrix A and it tells me, well, what size is it? Well, I know it's a 2 by 2. So I'm going to just type in 2 arrow arrow by 2. And look, it instantly changes to give me what I need. Then I just type my numbers in. Well, I've got negative 5. Make sure you use the negative term. And then when you hit enter, see how it just moves you over? Negative 8, when I hit enter, it's going to put me in the next spot. Negative 1, enter. And then negative 4, enter. So now I have my matrix filled. Here's what's so cool. When you go back, hit second quit to get to the main screen, you know how the question asked, what's 2a? All you're going to do is type in 2 and then Go to the matrix again, but instead of editing it and typing it in, we're just going to put in A. Look what happens when you hit enter. You get the correct answer. -10, -16, -2, and -8. So you literally could spend forever doing all the multiplication, or if you're very careful, you can type it into the calculator and let the calculator do the work for you. Why would you not want to do that? Now, there's going to be some questions, probably DOK2, that have variables involved. So in those cases, obviously you wouldn't do it, but nonetheless, it just works. Let's look at this again. We're going to go to center second matrix. I'm going to edit my first one. I don't need that table anymore because I'm moving on with my life. So now I just put in my new numbers. 5, enter. 1, enter. 4, enter. 8, enter. Now I make sure I typed it in correctly. Yep, 5, 1, 4, 8, perfect. Second quit puts me on the home screen. It wants me to find 3A. So I'm going to type in 3, go back to my matrices, put in the first one for A, and there's my solutions. 15, 3, 12, and 24. So this is my answer. So do not make yourself do more work than you need to, because sometimes it's not going to be that hard. Now, sometimes it will be. So here's kind of like a DOK2 type question that we could do. It's the same idea. Here we have a 2 by 3 matrix. So I know my answer is going to be 2 by 3. So I'm going to just set it up so I know where to put everything. Now my first thing is, oops, I've got this -4W, and I'm going to distribute here. A negative times a negative is positive, so I'm left with +4. W times W is W squared. Then I do it again. -4W times -4. Negative times negative is positive, 16. And then I have the W. And then -4W plus U is just going to be -4UW. That's all for that whole line. Here it's just 0. Any number times 0 is itself. And then you do the same thing again, but this time on the bottom row. So -4 VW will be here. Here we have negative times positive is negative, so 20 VW here. And -12 W squared V. Now, transparently speaking, I don't know if you're supposed to have certain orders with the letters, but that would be the basic way to do those problems. All right, here comes another one. Now, I picked this one because it's a good transition for where we're going, because look it has our scalar factor, but we also have to add. So the first thing you're going to do is order of operations. So first, this -4B, 2B, and 6B are just chilling. They're on vacation. Now I have to figure out what my new numbers are. Well, 2 times 3A is 6A. 2 times AB is 2AB. And then 2 times A is 2A. 2 times 4 is +8. So now that I've done that, now I can add it up to continue on with my problem, because I did order of operations. So then when you add it up, it's like literally you just smush them together. Here I've got -4B plus 6A. Now your teacher might make an argument that you should write the 6A first, because usually you put it in alphabetical order. Here we've got 2B plus 2AB, and again, they might expect you to switch it to put it in proper math order. And then here we've got 6B plus 2A plus 8, and again, we just switch it up to get our solution. It's that simple. Okay, that's scalars. Now here, again, we do add, subtract, multiply matrices to be appropriate. Don't remember, anytime that you add, the matrices have to look exactly the same. Anytime you subtract, the matrices have to look exactly the same. It's a little bit different when you multiply, not by a scalar, but when you multiply a matrix by a matrix. And I'm going to show you that coming up. Okay, here we see that we have 1 row by 4 columns. Here we also have 1 row by 4 columns, so we can do this work. We know that our answer is going to be 1 row by 4 columns, and then we literally just add it up. 6 plus 1 is 7. -5 plus 0 is -5. 3 plus 1 is 4. And last but not least, negative 5 plus 0 is negative 5. And your answer is done, except that's a negative. It's literally that simple. Here's another example. Here it's subtraction. This is when it gets a little bit harder. So here's a trick. I make this a positive, and then I change every single sign inside the second matrix. So this becomes positive. Where's my red? This becomes positive. So that means this is positive, this is positive, this is positive, this becomes negative, this becomes positive, this becomes positive, this becomes negative, this becomes positive, and this becomes positive. Now all I have to do is add. So here I double check that I have a 3 by 3, and I'm adding a 3 by 3. So I know my answer is going to be a 3 by 3. So then we just add across. Now, 2 ways that you can do this problem. Before I even changed all the signs, because I'm doing old school, what could you have done? Probably the better way would have gone right to your calculator, second matrix, go over to edit. Now this calculator is a 3 by 3. This calculator, this matrix, and then just type all your numbers in. Negative 4, negative 5, 5, 1, 6, 3. Wow, this is a lot easier if I would have just done this to begin with. Okay, that's in. I'm going to go back to the matrices to go down to the next one and plug in my B1. I'm going to plug it in the way that it was written instead of me changing the signs, just so we can confirm it. So before it was negative 6, negative 1, negative 6, negative 6. Oops, nope, that should be positive 6. Clear. Positive 6, negative 3, negative 2, positive 4, negative 1, and negative 3. Okay, so we know now by going to math, remember we're supposed to be subtracting it, by matrices. We know that we can just do, whoops, my bad, second quit. Now we can do it. Now we can go to our matrix, put in A minus, what do you think we're going to put in next? Not that one. B. I'm just going to hit the 2, and that's the answer. But let's just double check. So that's the fast way to do it, I guess. Here's the mathematical, if you like to do things in your head. Negative 4 plus 6 leads me positive 2. Negative 5 plus 1 is negative 4. Positive 5 plus 6 is 11. 1 minus 6 is negative 5. 6 plus 3 is 9. 3 plus 2 is 5. Negative 2 plus negative 4 is negative 6. 2 plus 1 is 3. And 1 plus 3 is 4. And we get the same answers. So one way is if you see a negative, then you're subtracting the matrix, change all the signs. Probably the easier way is if there's no variables, is to put all the numbers into the calculator. Okay, we are almost done. Okay, here is another problem that we're going to just put it in the calculator because it's ugly. And we don't like ugly problems. So I'm going to go to edit. I'm going to edit the first one. I notice this is 3 rows by 2 columns. So I'm going to change it to a 3 by 2. Then I just type the numbers in. 1, 0, negative 2, negative 3, positive 6, negative 6. Okay, I just did my first one, so I'm going to do second matrix, go over to edit, and this time I'm going to edit the second one. I'm going to edit B. That again is a 3 by 2. So I type in my numbers. Negative 5, positive 4, negative 6, 0, positive 4, positive 4. I've put everything in, so I'm going to go back to my main screen. Then I just type in the whole problem. The problem says what's negative 5 times, and then we have this whole idea. This is matrix A. This is matrix B. So really, I'm going to be typing in this. So I've got negative 5. Then I'm going to put in my named matrix, the first one, A, plus my name matrix B, close my parentheses, and I get the answers. It's that simple. Okay, so really with matrices, take your time, enter them into the calculator, see what you end up coming up with. Same thing for here, like with multiplication. Multiplication is a little bit tricky, but you just have to kind of go in order. So for multiplication, let's take a look. Here we have a 2 by 2. Here we have a 2 by 3. Because these inside numbers are both 2, that makes us happy. Whatever these numbers are, these are going to give us our answer. So I'm happy because 2 and 2 matches up, and my answer is going to be a 2 by 3. So I'm going to draw a 2 by 3. Now this is where it gets a little bit tricky. When I'm trying to figure out this number is in my first row and my first column. So I'm going to have to multiply 3 times 2. I'm going to just write it here to get 6. And then I'm going to add -3 times 6. -18. All right, let's look at it again. Here, this time, we have still the first row, but we're filling in this one. So we're going to look at the second column. So again, I've got 3 times 6, which is +18, -3 times -5, which is +15. Now, yes, way faster to put it into your calculator. I'm doing it this way to teach you because a couple questions from now, you're not going to be able to put it in your calculator. Then we look at the next set of numbers. I'm still in my first row, but now I'm trying to get this column. So I've got 3 times 1, which is 3. And then I'm adding -3 times +4, which is -12. Okay, so we are back because I somehow messed up the bottom. So we're going to double check the bottom again. So here we're looking for something in the second row and the first column. So I keep getting, why did I do that differently? So here we've got 6 times 2, which is 12. And we're adding 3 times 6, which is 18. Okay, that made sense. That's the correct answer. All right, let's see what happens the next time. All right, now we're doing this bottom row, the middle column. Oh, maybe the -15. I think that what I did is I missed the -15. So here, 6 times 6 is 36. 3 times -5 is -15. I might have missed the -15. And then finally, here, is going to give us this column here, which is 6 times 1, which is 6, and 3 times 4, which is 12. Okay, now let's do our math and see if we get the correct answer, because I don't know why I messed that up. 6 plus -18 is -12. 33, -9, 12 plus 18 is going to give you 30. 36 plus -15 is going to give you your 21. And then, of course, 6 plus 12 is 18. That is correct. Woo! Using my brain today. Okay, next. This one's way easier. Here we have a 2 by 2. Here we have a 2 by 2. So because we have a 2 by 2, yep, that works. And we know our answer is going to be a 2 by 2. So, first row, first column. 3 times 1 is 3. 1 times -4 is -4. Then we look at our next column. 3 times -3 is -9. 1 times -1 is -1. Our bottom row and column, here we've got this. -3 times 1 is -3. -4 times -4 is +16. And finally, -3 times -3 is +9. -4 times -1 is +4. Let's add it up and see if we get it. 3 plus -4 is -1. -9 plus -1 is -10. -3 plus 16 is going to be +13. Hey, we got that one right. Okay. Let's just kind of jump ahead because we're already kind of at the hour. Okay, this is going to be, let's go to 14. Here we have a 2 by 3. Here we have a 3 by 2. Okay, both of these match. So we know we can do the multiplication. And we know our answer is actually going to be a 2 by 2. So here we have our first column and our first row. So 6u times negative 3u is going to give you negative 18u squared. 2u times 6u, 2 times 6 is 12, we're adding, squared. U squared times negative 6u is negative 6u cubed. We're going to have to mesh all that together to make it pretty. This is going to combine to negative 6u squared minus 6u cubed, which we probably should rewrite again, but we'll leave it. Then we do the same thing, except this time we're not looking at this column. Now we're going to be looking at the second column. So we're going to do 6u times 1 is 6u. 2u times 3v is going to be 6uv. U squared times v is just going to be plus u squared v. And then we write all of that down here. 6u plus 6v plus u squared v. And again, your teacher probably wants you to write it in standard form. What did I miss? I missed one thing. Oh, I forgot to write the u in here. Okay, then let's look at the bottom column. We're almost done. Yay! Bottom, ooh, that's very dark. Let's pick a different color for the bottom. Again, we're going to look here. Okay, uv times negative 3u is negative 3u squared v. V squared times u is plus 6uv squared. And then here, negative times a negative is positive 12uv squared. And all of that ugliness gets to go right here. Okay, and then finally our last ones, which I'm just not going to squeeze in. We'll give you uv plus 3v cubed minus 2v cubed. And I wonder if they wanted you to move it together. They did. You can combine these, so you'll get uv minus v cubed. Or wait, plus v cubed, because 3 minus 2 is 1. Okay, that's pretty much all I wanted to show you. The only other thing, which I'm not really confident on because I don't know what the style of your questions are going to be, is one of the AKS, you get 3 questions regarding matrices, and it says use matrices to represent and manipulate data, to represent payoff. So the only questions I could come up with are these 2, where basically they give you a story, and they give you data, and then you have to do something. So like right here, it says, Mr. Gabrielli teaches French and Spanish. This chart shows the mean scores of the vocabulary sections, the comprehension sections. It's got vocabulary, comprehension. They pulled the data out for you already, where the vocabulary is V, and that's 32, 39, 41, 45. The comprehension is C, which is 35, 42, 39, 43. And then they just want you to add them up. That's it. Okay, so it's the same type of math, but you're just adding it up. Again, you can put it right in the calculator, let the calculator do the work for you. Over here, same type of thing. It gives you 2 different ones, and it wants you to find m plus t. So you're going to put it in the calculator and do the work. Okay, so I think I've covered 12 questions of your test. So hopefully between this and watching the videos on, I didn't have autosave on, and watching the videos on GwinnettMath.com, you should get yourself at least to passing. Fingers crossed, hopefully much farther. Not only that, but if you go to GwinnettMath.com, okay, everything is laid out by days. There's also this really cool study playlist that someone else put together that I just threw up for you. He teaches like so many things, and he teaches it 1 question at a time. So if you hate watching long videos, that's something that you can kind of do, is watch the first couple of seconds and be like, do I need to know how to do this problem? Yes or no? If not, just keep moving on. Again, this video probably won't help you too much. I watched all of it to learn more about the unit circle, but you have the unit circle on your formula sheet, so you might not need it. A couple of the things I didn't go over was this section here about parabolas and ellipses and hyperbolas. Your formula sheet does have those questions right here, which I got logged out of. But it does have those formulas that you can look at. Oh, here it is, the conics. So those might be good videos for you to look at. And then continuing down, I didn't cover vectors either. So this was intended just to be like a little bit of help to you. Hopefully it worked a little bit. And then we'll just leave it like there. So this is Doc. Have a good night. Ciao.